let us discuss about the next topic is non-contact forces. In non-contact forces, we can call the non-contact forces with another name or force at a distance, force at a distance, or field forces, or we can call them as field forces also. So here in non-contact forces, these are the examples. I have written three types of forces there. So if you observe, first one is magnetic force. We know that, suppose assume that this is a bar magnet. If you place any iron particle near the bar magnet, assume that this is an iron nail. So this nail will attract toward the magnet and it will stick on to the magnet. Okay, like this. So here, if you observe, if you want to join the pen and the cap, here I have to apply the force. This force is called contact force. Here the nail and the bar magnet, they both join together without any physical contact. That type of forces are called as non-contact forces. So non-contact forces is nothing but the force of attraction between two objects without any physical contact between them. That is called the non-contact forces or force at a distance, or we call them as field distance also. So first one is magnetic force. So this is an example. Now coming to the electrostatic force. Suppose if you take any scale, plastic scale, okay, and if you rub that scale to your hair and if you place the scale near any tiny papers, what happen, you observe that that papers will attract to the scale. That is because whenever we rub any two objects with each other, the charge is produced, and that is called electrostatic charge. And because of that electrostatic charge, force is generated, and that force will attract the small papers, and that force is called electrostatic force, and that is also non-contact force. Now coming to the gravitational force. If I release the pen, what happens? Definitely it will fall down. So here also, this pen was attracted by the Earth's gravity. So that gravitational force. So this is also non-contact force. So the objects which are attracted towards the Earth, okay, towards the ground, that force is called as gravitational force. So all these are the different types of forces, and they are non-contact forces. Okay. Now coming to the net force. How you calculate the net force? Assume that, suppose if this is a table, this is a table. Here one person is standing over here and he is applying the force. So the force, we use arrow, okay, we use arrow to denote the force. Assume that the person is applying the force here. What happens? Definitely the bench will move, okay, to this position. Yes or no? Suppose if another person is standing over here and he apply the same force, suppose he is applying, assume that 5 newtons, and here he is applying 5 newtons. What happens? The bench will remain same. Force, Newton is a unit of force, that you have to remember. The SI unit of force is Newton. So what happens? Suppose if this person applied 10 Newton, definitely the bench will move towards the right side because his force is more. So how we calculate the net force? How you are saying that how much force he is applying? We can directly say that the net force is equals to 10 Newton minus 5 Newton. So 5 Newton is the force. So 10 Newton is more, so that's why the object will move right side. This is one example. Suppose if some examples you may get like this also. So if two persons are standing over here and both are applying the force, definitely it will move. So more force will be applied on that because more persons are applying the force. Now coming to the free body diagram. So how you calculate the free body diagram? So any object. So we know that on every object different types of forces will acting. On this board many forces are acting. I said tension force, weight always act in the downward direction. Suppose if I observe, assume that this is a car. A car is considered as a free body diagram. Okay, assume that this is a car which is on the road. Okay, a person is sitting in the car. So assume that this is a car and this car is on the ground. We know that the normal force will act in the upward direction. Assume that these are the normal forces. We know that weight always act in the downward direction. Yes or no? So weight always act in the downward direction, and the normal forces will act in the upward direction on the car, And similarly, if you observe, so if the person will start riding the car, what happens? The car will move in front, in forward direction. That is called applied force. Here he is applying the force, so applied force. And similarly, on the surface of the ground, so in opposite direction, frictional force will act. So on this object, how many forces are acting? Many forces, that applied force, frictional force, normal force, and weight. Total 4 type of forces are acting. So if I ask, so what is the force? Suppose if I ask what is the net force, suppose assume that this is a, you know, the graph, this is the x-axis and this is the y-axis, assume that this is the x-axis and y-axis. So here consider these two as x-axis. If I ask what is the net force means total force acting on x-axis. So what you will say here? So F, capital F minus small f. That's the net force. Suppose if I ask what is the net force is denoted with F net. What is the net force acting on y-axis? Then you can say that. So see, you observe normal forces are acting in same direction. So I will add like this, N1 plus N2, and weight is acting in downward direction minus W. This is the way to calculate the net force, and this diagram is called as free body diagram. Let us discuss some more examples. Okay.